So, welcome everyone to the second day and third session of the 6 days FTP on driving the future, sustainable mobility through electric vehicle technologies and the MATLAB simulations. The FDP is being sponsored by the AICTE Training and Learning Faculty Development Program, that is ATAL. So, we are here to welcome Mr. Manoj, sir. Mr. Manoj Kumar is the Assistant Manager, Technical at Design Tech Systems Private Limited, where he has worked with MathWorks products for over 6 years. He collaborates closely with the universities, government organizations, and the industry partners to understand their technical needs, deliver the tailored demonstrations, and recommend the MATLAB solutions as well. That will enhance the productivity and optimizes the workflows across the organization. Before joining Design Tech, he has worked for over 4 years as an assistant professor at DBIT Dehradun, and he has also more than 2 years of industry experience as an automation engineer. Sir holds a bachelor degree in electronics and communication and certification in advanced embedded systems. We heartily welcome you, sir, to the second day of the FDP, and I hope the participants will get benefited from your expertise.
Thank you, ma'am. Thank you for the introduction. So,
So, session is over to you, sir, now.
may I receive my screen?
Yes, sir. I'll just please let me allow to host you. You're now the co-host, sir, and you may please check the share screen option.
The option is not enabled right now.
It's enabled now.
We'll share again. Yeah, ma'am.
Okay.
So I hope my PPT is visible and audible, ma'am.
Yes, sir. It's visible, sir.
Okay. Thank you. So thank you, ma'am, for the introduction, and good evening, everyone. And thank you, everyone, for joining the third session of FDP program. So on the behalf of the Design Tech and MathWorks, I'm thankful to just invite me for a whole organized committee. So in today particular session, we'll explore that MATLAB and Simulink, why it is useful for your EV modeling and simulation. We'll just go through the introduction part. What are the new features are available within the MATLAB, and if somebody is new for the Simulink, how you can just use model-based design to simulate your EV modeling. Through which I will also share you if somebody is new for either for the MATLAB, mostly aware here MATLAB and Simulink, but I'm going to share you a lot of resources which will be useful to explore your EV modeling, as well as I'm going through that what are the complete course I'm going to share with you, the MathWorks design for EV modeling, and we will explore a few chapters from that. And in the upcoming session also, my colleague also from the MathWorks as well as from the Design Tech will discuss you more chapter which are based on the some advanced like your thermal analysis or whatever other tool given like powertrain blocks that is given, so that you can quickly your EV modeling for that. So this is a brief agenda. We'll explore that what are the new feature available with the MATLAB as well as the Simulink, and little bit background of EV. What are the MathWorks tool are available for EV designing, and what are the learning resources, and we'll take some question answer session. So everyone is aware that MATLAB is a product of MathWorks company, and the tagline of MathWorks is accelerating the pace of engineering and science. So as you are aware that MATLAB is just a programming environment, or it also provides you the some algorithm development environment, so that you can also write your own algorithm within the MATLAB. It could be used for your data analysis, visualization, and while it could be used for numerical computation. But we have a dedicated toolbox in MATLAB that we have the symbolic math toolbox. So we can also do our symbolic computations with MATLAB also. As you know, apart from the MATLAB, on the top of MATLAB, we have this Simulink environment. Basically, this is GUI based environment through which you can design, simulate, and test your any dynamic systems. So we'll explore that how it will be useful uh, for your EV modeling and what are the features are available for EV modeling also. Apart from that, as you are aware that more than 100 toolboxes are available on the top of MATLAB, which could be used for different type of applications area. Either you want to involve some AI part into your EV, we have the statistics, machine learning or deep learning, image processing. If you want to just working with some type of sensors, different type of, so there are multiple toolboxes are available as per your requirement. So first, I want to share you the course, how this course you can access. So right now, if you're just using your laptop or so you can just open a new browser and you can type this URL www.tinyurl.com slash MATLAB modular. So that we can also just see that how you can access this course and what are the different files are available. So just please open your new tab and write or access this URL www.tinyurl.com, or let me also paste this into chat also so that so through this you can click this link. Okay, I hope you have just access this. So how it will work, how you can access. Uh, so let me just open a new tab for you. So you can type here www.tinyurl.access. This particular link you can note down with you or bookmark with you. So once I will just enter it, this link, so it will just open the this drive particular drive link for you. Maybe it will ask your MathWorks email ID. So right now, if you don't have the MathWorks account, so parallelly you can just access this MathWorks account. And once you access your MathWorks account, either you are the part of the campus file license, or right now if you don't have the campus file license, so using your personal email ID also you can access this drive once you create your MathWorks account. So in this drive link, there are multiple courses for your teaching purpose. Okay. So apart from the electrical vehicle, we have other courses also, but for today session, we will explore more on this electric vehicle course. So how you can add these courses into your personal drive, personal MathWorks drive. So just click on expand this plus sign and click on copy folder. Click on the copy folder. Once you will copy it, it will be this the whole course will be automatically copy into your MathWorks drive. So what is MathWorks drive? If you right now don't have the MathWorks license, so you can just visit on the mathworks.com, sign in into your mathworks.com, and once if you click on this MATLAB option after signing in, you can launch the MATLAB online. Okay. So if you go to into your MathWorks account, so if you don't have the license with you right now, you can just get a trial license, click on the trial license, and the MathWorks will provide you 1 month trial. That trial license you can access through MATLAB online also. So no need to install the MATLAB. You can access this MATLAB online. You can click on this MATLAB, and once you will open this MATLAB online, whatever the code you have copied, it will be automatically will be added into your here. So the whole course you can access. So this folder name will be available into your MATLAB drive. The folder name is modular curriculum, and you can just explore this modular curriculum. Maybe I have lot of folder here, but one folder will be so once you go to inside this modular curriculum, there is course is available to you. So are you able to access this? So this is available like electric vehicle course is given. The whole course is divided into 16 chapters. So we'll explore it that what are the different chapters related to which particular concept. So this is how you can access these courses. So we'll explore it. So later on, so this is a particular link to access these courses. And what is inside these courses, you can just go through that overview of EV courses like introduction to model-based design. We'll discuss what is model-based design. And in your EV designing, there are multiple things that you have to involve, like your power electronics, battery molding, vehicle dynamics. And if you are or 54 color ambient lighting. Sir, please. Okay, thank you. So solving your OD using the block diagram method, as well as how you can just integrate your hardware and code generation, BMS, system level. So all the concept you will just go through step by step in this. So if we talk about the electrifications of everything, like we will talk about mostly that why it is happening and what are the challenges in industry facing and how are the engineers overcoming through them. So not going to in the detail, but if we talk about the climate change, this graph is given by the OECD, and global greenhouse gases are there. So how much percentage of the transportation industry, everything is electricity and heat production, everything is given. But will concentrate on that why this electrification is important and in the form of the renewable energy. If we talk about the renewable energy, government also they're providing some subsidy also for developing this. But if we talk about the perspective of the EV industry, so MathWorks work with the EV leaders in the electrification. Like here are some giant organizations like Tesla Roadster. So these user story are given as a link on the MathWorks website also, that how these industry of related to the EV using MATLAB Like this particular user story, Ether Energy. Ether Energy actually it is a startup of the Indian base, and they actually design this EV scooty with the help of the MATLAB Simlink and their charging station also. Okay. Another like LG BMS development, how this LG is using this one, Volvo multi-domain system modeling. So there are a lot of industry also using as a MATLAB tool for their product development. So it is not that electrification of the Nikkei anymore, that vehicle also just gaining the market acceptance. If we talk about the technology progress or what are the lithium ion battery price outlook, if we talk about this, that how the price is going on decrease through this and greenhouse gases requirement it will be. Now, if we talk about the electric vehicle architecture, basically will mostly there are multiple type of electric vehicle, but in this session we'll explore the BV battery electric vehicle. So if we talk about the architecture of this electric vehicle, so it contains lot of component like we have the battery. Sometimes we have to work on the converter, charging, transmission, onboard charger, or vehicle body. So if we represent this in the form of some block diagram, so just we'll discuss about the drive, what is drive cycle, how you can implement or test your particular vehicles on different drive cycles. Then we have to design the controller, how you can design the controller part. Then power electronics also involved, cooling system, how you can just include the thermal behavior of the system also, and vehicle dynamics. So what are the big challenge for as a EV engineer? So electric vehicle development requires several design challenges that could be addressed at the system level. Okay. What is meaning by system level? That you can integrate your power electronics, high voltage battery, motor together to maximize the vehicle efficiency. So end-to-end interdisciplinary development from prototype to productions. And sometime once your model is ready, just you are going to design your hardware as well as the embedded software, that from your controller maybe you are going to generate different type of code for your hardware deployment. So this is again the vehicle electrification. Some examples taken from the different companies, like this is the Chevrolet Volt plug-in EV. This is your in 2017. Now another challenge that we have, the different components are available to design the EV. Like we have the battery. If we talk about the power electronics component, how you will model your power electronics component, and motor controlling. So if we talk about the in the detail, and we have to also develop the software to control these type of component. So if we talk about the battery part, so how you will just model your different type of battery, uh, as well as the shape, how you will make your set operation of the battery, aging optimization, how you can just optimize your battery age, and the most important, that how you can just manage your BMS development, battery management system. We talk about the power electronics part, like different type of dynamic simulation, digital controlling is required. We require the supervisory logic, and sometimes we require the rapid prototyping. In prospect of the motor controlling, that we require the sensor calibration, different parameter estimations, tuning of the controller for motors, and how you can just use your efficient algorithm for that. Again, if we talk about the challenges of powertrain electrifications, so it will be one challenge that how you can just going to select the component. Okay, like if we go to the type of motor, which type of motor you are going to use, which battery technology. Another challenge could be like component sizing, what motor sizes you have to just select. So you cannot just select directly as a hardware. So first you have to just simulate that particular your complete motor or either part of the motor into some software, and simply provide you the complete integration, or we can say the ID environment, so that you can also simulate your this type of. So this is the user story taken from the. They use the MathWorks tool, and what are the results they got? The Tesla got the calibrated system model, improving simulation accuracy, 100 of powertrain configuration tested, and multi-domain effect simulation enabled here. So what are the benefiting if you are going to work on the system level simulation? Like you can analyze the system behavior, evaluate the design alternative, and you can evaluate the your optimize your design also. Because you are working here in a single working domain, so we can just analyze interaction between our subsystems. If you will just make changes in a particular component, you will see the effect, that what is the effect is going on this size key component. So what is basically model based design, and how this MathWorks is started this. So basically, if you are going to use any traditional approach, and but how this model based design is different from the traditional approach. Like you are going to research, or you have some requirement related to your EV. So your research related or your requirement is directly related here or linked with your model here. Like you are going to design your different type of algorithm or different type of models into the Simulink environment, and Simulink provide you the complete environment for your multi-domain modeling. After just providing your algorithm, you can also incorporate your algorithm into some AV part, or your into the model. So maybe you require that you can also generate different type of code for your controller or BMS system. So directly we can also generate different type of code and integrate into different type of controller hardware. Now, if come to the MATLAB and Simulink, as you know, the MATLAB just provide you the environment, so that you can also write your algorithm in the form of some script. But Simulink is a powerful platform for model-based design. Basically, you can also incorporate your MATLAB algorithm into. So there is some function block is available. So if you want to just include some MATLAB algorithms, you can call your MATLAB functionality into Simulink also. Further, for your logic control, that we have the state flow. So if you want to just model your some transition into your logic, so with the help of these flow chart, we can also include some type of logics, and all the product also related to MATLAB, Simulink, and state flow. We can also generate the C or C++ code and other code also. Now the question is that how you can just implement the multi-domain modeling with Simulink and Simscape. So what is the difference? Uh, Library are available within the Simulink environment, that we have this Simscape product family on the top of the Simulink. So basically, let me just switch to the MATLAB. Okay. If I just type here doc command doc to launch the documentation of MATLAB. Okay. Now we have this physical modeling, physical modeling category. So inside this physical modeling, this is called the product family of Simscape. So there are 6 products are available. Like we have the Simscape, Simscape battery, Simscape driveline, Simscape electrical, Simscape fluid, and Simscape multi-body. So these all the 6 products just provide you the library related to your different type of domain. Either you want to just include your some type of your rotational translational part, maybe you want to include some hydraulic, or this dedicated toolbox is available for your battery design. Okay, we'll explore it. So let me just switch to MATLAB little bit just before going to. So I have this BEV system model where you can find out. So just I'm going to start here from a big picture, that this is a uh, Simulink model or of your battery electric vehicle system, and it is designed with the help of the MATLAB Simulink. It contain your complete, like we have the this GUI also created for that. You can also create that. I will also show you that how you can also create some dashboard for that. But this is my drive cycle. Okay. So I'm going to test this vehicle on a some drive cycles. As you know, there are different type of drive cycles are available. So if this component you can find out into uh, Simulink library. Or I have just share you the courses. You can also access this example through this. So I think you can start to open this example from your this EV course, and it will be better that if you can just see the big picture, that how I can develop my EV model into this one and rest. So you can open this. Just go to the 15th chapter here. Okay. So inside this 15th chapter, we have this model is available. So complete EV model is available. So this is BEV system model. Okay, this is the same model. You can find out this model into chapter number 15, BEV system model. That we have that this drive cycle. Okay, we have this HMI input here, whatever the HMI is given to here. Okay, now if you just go to the controller part, double click on this controller part. This is the controller part. Okay, so this is the dashboard input is coming here. BMS, range estimator, thermal control. This is the vehicle controller part. Cabin control part is available here. So we can just explore these subsystems. These are the energy consumption, how the energy consumption is going on. And this is the vehicle electrothermal part includes. So if you just go to inside this, so these are the wheel drive is there. This is the front wheel. real motor DC-DC converter. Okay, this will show you your ventilation AC part here. This is the heater, or this is the battery pump. So this is a complex system that everything is designed. If you go to the drive line part here, so there are some multiple components are available, like your front tire, rear tire. So these components, will see that how you can find out these components to designing your different type of structure to MATLAB. So these are the part of your, okay, this is, now if this I want to test this vehicle on this particular drive cycle, this FTP 75 for 1180 seconds. So let me just run this, and it will just show you the complete simulation. Maybe I have not included. Okay, I have to just include this in the path. I have just downloaded this and rename it with that GitHub. So you can also, it is already in the path. Mhm. Maybe I need to close it first.
Sir, one of the participants is sharing in the chat window. I can't able to open the curriculum in my MATLAB desktop as it is asking 2025A version. Is there
Okay,
any
let
other way,
me.
sir, to open that? Um, so please click on the chat option.
Mm. Right. Yes, sir, the MATLAB is okay. Yes, you can use the MATLAB online. So it will be Soda, and other have the, okay. So there are two ways, like you can access this drive. So right now what you can do, you can just open this drive.mathworks.com. Okay. This is your drive.mathworks.com. So here your all the course will be available. Okay. But inside this drive, you have a lot of courses. If you want to download any particular courses, maybe you have the EV course, you can download it. Okay, you can download it, and now you can just use this one. So what version you are using, it is not compulsory that you have to just use the 25B or 25A. So some your course will be run on also in the some old version also. So first download it, download these courses into your local system. Or there is another way also, if you want to sync your this MathWorks drive. So we have a you have to just install the this MATLAB drive connector. Just install MATLAB drive connector into your system. This install the MATLAB drive connector. Okay, once you install this MATLAB drive connector, so it will sync your MATLAB drive into your local file. So from, let us say I have just installed this MATLAB drive connector. So it will take some time, but it will just enable this option. You can access your MATLAB drive into your local MATLAB. So now I'm able to access this MATLAB drive into my local system. Okay. So now you can access. Either you can download this setup. Maybe some particular version will be required, but it will not ask like you have to run it into 25A. Okay. What version you are using right now?
So 17, sir. MATLAB 17.
17.
Yes,
So
sir.
right now just shows you that you can also just access the MATLAB trial
So can
version.
you share your screen, sir? It is not visible for us.
The screen is not visible. Okay. So, okay. So right now, what you can do, you can just create your MathWorks account and you can access the MathWorks trial version. Okay. Trial version. So through that trial version, you can access this MATLAB. Maybe some file is missing, which could be useful into as you know, the MathWorks release every time some products. So this like we have recently added this SimEscape battery. So this SimEscape battery is not part of that time. So maybe it was added into 2 or 3 year back. Sometime it asks, but not for all the model. Okay. Now this I will run it. Okay, no problem. But I want to show you that how you can step by step just other learning resources are useful to you. Okay. So once you create your MathWorks account and go to your MathWorks account in the My Account section. So there are this My Courses option are available to you. Inside this My Courses option, if somebody want to just explore the fundamental of MATLAB, if you want to just uh, refresh your knowledge related to your fundamental MATLAB, so there is 2 hour course step by step is given to you, and you can also generate the e-certificate from that. So this MATLAB course is available. You can refresh your knowledge. Let us say maybe somebody is want to refresh the knowledge on the Simlink also. What are the new features? Maybe some people are working on the old version of MATLAB. So this Simlink on-ramp course is also available to you. And other courses, if you go to the Simlink part, so here we can just shortlist these courses based on the Simlink course. So all the Simlink courses, if you click on this all Simlink courses, so there is one course is available. This is called SimEscape on RAM. So if you want to work on multi-domain system modeling and you want to explore the SimEscape, this course is very useful, which will be useful that how you can just do the multi-domain modeling. So it will just teach you all the fundamental concept that how you can interface multi-domain systems, how you can create the uh, different type of subsystem with the help of this SimEscape library. So what is the difference between Simlink or this library? So let me just open one example here. Let me try again it. Maybe some file is not. So it will take a little bit time to simulate this whole easy part, but it will take little bit time. So let me just explain you that what are the other courses are available in between. So these courses are related to your Simscape. Once you complete it, it will just give you the e-certificate also. Okay. Apart from that, maybe some power system related motor control course also available. Okay. And one more important, if you want to work on the battery design, so this Simscape battery on ramp also given to you, that how you can use these product. Let me just uh, open the doc. As you know, a little bit like somebody is that we can divide all the EV courses file into two category here, like .mlx file. What is MLX file? So in the MATLAB, you are aware about, mostly you are aware about that we have this live script. So generally on the live script, we write our programs. Okay. But apart from this simple script, we have this new live script. So inside the new live script, we can just insert our text part during writing our like I want to insert some text. So just I will insert here like my EV modeling, or I can give my any topic name EV modeling. I can make this as a title. Then I can just insert the theory part, anything inside this live script. Now inside this live script, now I want to insert my some code, MATLAB code, or either I want to just call some Simulink diagram. So I can insert here some code part. So this is your code will be executed, and whatever you are going to insert into this script or this text part, it will not execute it. Okay. Once you will save this file, go to the save as. So the syntax will be .mlx. So this will be your .mlx file. And second file is in the MATLAB is called the Simulink. So how you will launch the Simulink part? So there is one option of to launch your Simulink. So here we have this Simulink. Basically, I just told you that Simulink is a model-based design. So if you want to start to building any type of dynamic system, you can just open this start page, and we can open this blank model. Now to model any type of system, we require the components. Okay. So you can access the component through this library browser, and this Simulink library is available. Okay. This is the Simulink library with the name of the Simulink. This whole environment is called the Simulink, but with the name of the Simulink, we have the component related to different type of tasks is available. We can insert these component on this into this canvas. Okay. Now the difference is that let me just give you the idea that how many type of modeling approach is there. So if we talk about the modeling method of any type of system, so there are two type of modeling method. One is called first principle method. First principle method means this is your physics based method, or it is called the mechanical method. So through which you are going to convert your mathematical equation into some type of system, okay, or some type of circuit. This is called your first principle method. So mostly with the help of the Simulink, we generally just follow this mechanical modeling method. Nowadays, we have the data driven method also, like lot of data is generating from the different parts of the component. Like we want to just build some AI model through this data, and this is called your data driven method. But nowadays, if you want to just integrate both method, like we are just going to generate different type of smart systems, like we want to just generate some driverless car. So in the driverless car, the we have to use both method. We have to just go to for modeling method for hardware of that particular car, as well as if you want to involve some AI feature into this that car, so we have to just integrate both methods. So MATLAB or Simulink provide you the complete environment. You can also use the Simulink for your first principle method, as well as you can also use the AI based tool for your data driven method. Okay. So if you want to design any type of system, there are two methods are available. Okay. And I told you that, let us take one example, like how you want to generate this DC motor into Simulink. Okay. So just I want to explore here two example. There are two approach of mechanical method. One is called the mathematical modeling. Okay. What is meaning by mathematical modeling? In mathematical modeling approach, you have the mathematical equation of your system. It could be your DC motor, or it could be your mass spring damper, or it could be your maybe series RLC circuit. Okay. But you have the mathematical equations of your system. It could be any type of system. So how you will combine your mathematical equations with the help of these Simulink blocks. So I just show you the Simulink library. Inside the Simulink library, I don't have any physical system here. I don't have any register. I don't have any mechanical component, translator, gearbox, and nothing. I don't have, or I don't have any mass spring component here. So how I can design this type of RLC circuit, or could be some type of DC motor. Okay. So let me just switch to this course. Okay. So still, if you are just facing, anybody is facing issue to accessing this course, so you can connect me later on. I will share my mail ID or okay. So let me just switch to the courses. What are the courses and how you can just explore the DC motor modeling or other type of. So I've just run this. Actually, this simulation has done for this. Okay. So simulation had done for this drive cycle. So what is meaning? As you are aware that drive cycle means you are going to test your electric vehicle. There are different type of drive cycles is available, European, USA. Okay. So now you can see that how your speed, and it is showing your complete dashboard. Okay. This is showing the uh, state of charge of your battery. Initially, maybe it was on 80%, but as you just test your system, and it is showing me the range. What is the range? Established range is 310 maybe in a kilometer. Okay, for this cycle. So it will, you can also estimate the range. This is the energy per distance, and how much distance you have covered right now, around 10.93 kilometer for this 1180 seconds. So you can just see in the graph that you have just vary this speed, sometime low, high. Okay. So it will show your all the what is my ambient temperature within the cabin temperature. So this is the overall, just we have this complete BV system model. But to learn this model, we have to explore these chapter. Okay, step by step, how you can learn to model your complete system. Just I share you the course, and this is my MATLAB online. This is my MATLAB online. So in the EV course, I share you the total. So you can just go step by step that EV course overview. So inside the EV course overview, that what is the PPT I am discussing here. So you can just open this PPT also. Everything is, maybe first you have to download it. Okay, you cannot open in MATLAB online. Okay, so it is, you can download it and you can open it. Okay. So just go through this PPT. It is in the two form, PDF as well as the doc. Now, the first chapter is introduction to programming. If somebody is new for the MATLAB, so these are two type of file you will find out in the whole course. Okay. What type of file? I have discussed with you that one is .mlx file. So how you can create the MLX file that you can create, but these are the ready to teach files. So if somebody want to just introduction to MLX, this is how you can call the functions plotting. So this first chapter, if somebody or maybe your student is, you are teaching this course and your student is new for the MATLAB, so you can also just open these script, uh, live script in front of your student also, and you can teach the introduction of MATLAB, that what is MATLAB programming language, how you can just enter some constant or some variable into MATLAB. Then now you can just guide that what is, how you can sum of two variables. So this is a fundamental script. Okay. And step by step you can run any section of code and your output will be come, that how you can write the function. So this first chapter related to your introduction to MATLAB. Okay. Further, just giving the introduction to MATLAB, you can also just recommend this MATLAB on RAM course, MATLAB on RAM. If you are just going to teach your student, so this MATLAB on RAM, they will also earn the e-certificate and they will know the fundamental of MATLAB. Okay. So once fundamental of MATLAB and some fundamental of Simulink is required, then we can just switch to the EV part. Now, third course that I will recommend, that you have to just work on the Simscape on RAM. What is difference in Simscape and Simulink? Let me just explore with one example. So I have here, so you can understand that what are your different modeling approaches there. So I will open here. Let me simple. This folder is not part of your this course, but to understand the difference of mathematical modeling approach and physical modeling approach, then we can move to the DC motor modeling. Okay. So let me open this simple example of series RLC circuit. Okay. And this is, I can say, this is the modeling of series RLC circuit. So everyone is aware about the mathematical equation of series RLC circuit is L dq dt square plus R dq by dt 1 by C q equal to V in. Just I have given you the task. Maybe you want to design your or model your mass spring damper. So for mass spring damper also you have some mathematical equations. Maybe for another part of system you have some mathematical equations. So how you can combine this mathematical equation into some blocks of form. Okay. So maybe, so how it will be work, that let us say I have a equation of y double dash. This is my, so here we have the highest derivative term is dq square dt square. So you will arrange your higher derivative term into left hand side and rest you will just carry on the right hand side. So my equation will be V in minus RQ dot minus 1 by C and divide by L. So you are aware that if I have the integrator block, this is my integrator block, and inside it is the input. Like if you just put here second derivative, like you put here acceleration. So what will be my output? It will be my the output will be velocity. That means if you have the 2 degree of derivative, that you will get the dq by dt, or acceleration to velocity. Then again you will integrate your velocity, you will get the displacement. So in this case, I will consider it like this is my q dot dot. This is my q dot dot. This is my second derivative. I will get here q dot dq by dt. So I will mention here this is my q dot. Again, if I will insert here another integrator. So I will get here what I will get q. I will get the q. This is my q. But okay, now in the q dot, I have the multiplication of resistor. So I will just take here the resistor, some constant block, and in the q, I have the multiplication of my capacitor, and in the V in is my constant battery voltage. If you are just working on some mass swing damper, you can take the some torque or force. So instead of using two integrator block, I have used here single block, that is called integrator of second order. So I have considered, I have start my block diagram from here q dot dot. Then I will get the q, and this will be my q dot. That inside the q dot, I will multiply to the, this is my gain block. Okay, so this is my R resistance, and I can just provide the value of R here, and in the q, I will multiply with the 1 by C. Now this is my voltage. Voltage is constant, so I can take a constant block from that constant block. So all blocks are available here. Just go through, and if you are, so I will take here constant block, and if I just simulate it, this is my sum block. I will just put here minus plus minus. V in is my minus and rest are. So I will just use the algebraic sum of this equation here, and the result will come here, and I will divide whole algebraic sum with the L. So this, I can say this is my series RLC circuit. But what is this method? This method is called the mathematical modeling. So mathematical modeling of your system. So if you are just going to model any particular part of your system, so it is not always that you will find some blocks, ready-made block inside the Simulink. So you can build your logic using your mathematical formula. So Simulink component will be useful when you don't have the your logic, and you don't have the direct component is available. Okay, so this is my series RLC circuit. But once you are going to work on the very complex system, sometime you have to work on very some grid systems, power generator, transmission type of component, okay, or maybe some EV complex type of systems. So it is, or DC motor modeling. So if you go to the DC motor modeling and then the controlling of the DC motor, okay, for your EV purpose. So we have this course available. Okay, so inside this course, I've shown you that you have to just go to the different courses. Okay, so from this simple vehicle model is given introduction to MBD. I told you that what is MBD means. Model based design approach is what is this, and in this chapter you will study the DC motor control. But first, how you can model your DC motor into MATLAB or Simulink. Okay, so this example is given that this is the DC motor, and it is designed with the help of Simulink. So I already told you that if you have the equation, mathematical equation of your DC motor, so you can model any DC motor, this DC motor, with the help of mathematical modeling. Like this is the mathematical equation, and you have combined this DC motor, and you can simulate it. It will work same as your DC motor. Okay, now Now the second approach is, because I require some ready-made component to modeling my physical system. So for physical modeling of the system, inside this Simlink, or I can open the library of Simlink from any model, or I can open a blank model. And if I go to the Simlink library, so inside this Simlink, I have a product family. This is called Simscape product family. Okay, this is the Simscape product family. So inside this Simscape product family, we have 6 product families available. One is Simscape. Second one is your Simscape battery. Third one is Simscape driveline. So Simscape driveline contain the your component related to your driveline. It could be rotational or translational, some clutches, gear, different type of sensor, tires and vehicles. So you can also use this vehicle body, tire, different type of tires. All the components are given to you. Then the fourth is electrical component. So if you want to just work on the electrical as well as the some electronics component, so it contain additional component, different type of uh, BLDC control, PMSM control type of whatever the part of your. Then we have this hydraulic. This is for fluid libraries available. So inside we have this. We can also inside the some thermal library also available if you want to inside the thermal effect into your vehicle. And this is the multi body. So if you want to just design some type of 3D mechanical component, so all the pulley, belt, everything is given to you. So this library could be used for physical modeling. So if we take the component and just model our system from these library, so this is called the, let me open a example of this DC motor. So now I will open a DC motor, but it is designed with the help of Simscape library. Okay. So both are same. This is called the DC motor using physical modeling in the Simscape. So this model is also representing your DC motor, but we have designed with the help of this one. Okay, because these physical component and Simscape component are designed with different languages, so we cannot combine directly. Okay, so always remember some rules. If you want to design any model with the help of the Simscape, then you have to connect the solver configuration at any corner. It will take care the solver configuration. Okay, as you know, there are different type of solvers are available to solve these models. Okay, so always remember you have to connect one solver configuration at any corner of this one. And further we have this converter also. So PS to Simlink converter, if you are just going to carry your physical model to the Simlink component, because scope is a part of the Simlink component, so you have to just insert some physical to Simlink converter, and vice versa also we have this converter. So you can find out these type of converter component inside the this Simscape library. Okay, once you are aware about these component, you can directly search your any type of component like DC motor, like you can search DC motor or resistor, electrical, any type of component you can directly search. So just go through. And if you want to just explore more on this, so I just recommended you the Simscape on RAM course. So it will teach you step by step that how you can just insert the component from multi-domain and you can just build your model. Okay, so inside the utility library, we have these converter also, Simlink to PS converter, solver configuration block also available, spectral analyzer. So all the components are given. So to controlling your DC motor on any type of motor, first you have to just design how you can design your DC motor into MATLAB and Simulink. Once you are ready, that you can also go for the controlling part, that how you will control this. Okay, so inside this we have the control system toolbox. So if you go to the control system toolbox, so inside the control system toolbox we have the different type of this is the control system design analysis. The third important part of MATLAB is that these are the apps. What are the apps? Apps are that you can solve your different type of problem with the help of these apps without writing any line of code. So these apps are part of the different toolboxes. Sometime if let us say you want to just build some AI model like your classification learner app. So using the classification learner app, you can train your classification problem. We have the regression learner app. Inside the control system toolbox also, we have different apps are available, like control system tuning app is also available. Sometimes you want to design the fuzzy controller and you want to tune your PID controller also. So using that PID app, by dragging your slider, you can tune your PID controller. But if you want to tune your PID controller inside the Simlink, we have a toolbox. This is called Simlink control design toolbox is available. So using the Simlink control design toolbox. So I just want to open this example. So this is the example related to tuning of your PID controller. So this is my reference signal. This is the motor Simlink. So here it is a subsystem. So this is a motor and it is designed with the help of the mathematical modeling. Apart from that, you can also uh, insert this motor using the SimScape. Okay. Now this is my PID controller. I have inserted here the PID controller. If you simulate it, so it will just give you some reference output. Okay. So what is the best part of this PID controller? We have this automatic tuning option. If you just click on this tune, so this tune option will open the automatic tuning app option. That particular app, you can just, it will open and you can compare your reference signal, and with the help of this app slider, we can just easily tune our system here. Okay. Maybe it will be open in the background. Let me check. Lot of model is open. Maybe this is the PID to this one. Okay. This is this one. This will be automatically open, and using this PID tuner app, you can just move this slider and you can tune your PID controller. Maybe if you want to just, so it will show you easily, you can tune the PID controller, and once it will be so you can show the parameters. What is your target that what is your rise time is required, settling time, what are the overshooting you require. So you can just tune that controller according to your requirement. And if you just click on the update the block, the your parameter will be updated into your PID2. So this is that how you can work on the DC motor and controlling of the DC motor. So this chapter will guide you. Okay, so I will just explain you that how you can just control your DC motor, modeling of the DC motor. Okay, and it will be useful that how you can just utilize the capability of Simulink library as well as the your Simscape library. Further, in further chapter, you will just explore the capability of your power electronics related. Okay, so this power electronics MLX is given to you, how you can work on the to DC converter, DC to AC converter, which will be required to convert your. So okay. Code generation is the last part. Maybe you can go later on hardware code generation if you after this, if you are satisfied with your model, that how you can generate the code. So if we talk about the code generation part, so inside the MATLAB, as you are aware that we have different type of coder product also available. Okay, so if I just go to the documentation of MATLAB, there are different type of coder options are available here. This is the code verification, code generation code. Okay, so inside the code generation part, different type of coder is available as per your coder requirement. So MATLAB coder generates C and C++ code. If you want to just optimize code, you require the embedded coder. Then for HDL or different type of different code options are available. So every product work on different type of code generation product. But I told you that in each MATLAB we have the different type of apps also. So with the help of the apps, we can also, if you just type here coder, so different type of MATLAB coder. So with the help of these apps from the MATLAB code as well as the from the Simulink also. If you are working on the Simulink environment, so we can also generate the different type of C and C++ code from the MATLAB program as well as the this. So it will just teach you maybe some C code generation course also available inside the this one. Okay. Now working on other type of BLDC motor, brushless DC motor as well as the permanent magnet synchronous motor. So this chapter will guide you that how you can work on the BLDC motor, what are the different type of controlling. So in each chapter, okay, because you have the another session also, so my colleague also explore more in detail. But today that the thing is that you will aware that what courses are available to you and how you can just access the MATLAB resources. If somebody is new for the MATLAB as well as the Simulink, so every whatever I'm going to discuss today, every chapter will repeat these things. So this is a Simulink model. So in each chapter, either you will have the uh, some type of Simulink model SLX file. This is called the SLX Simulink file, or either you have the MLX file. So how you can access these type of file. So again, that this is the buck converter. All the examples are given, ready-made examples are given, and the mat file contain the data. What are the data is required for any type of model. So maybe this is your .mat file you have to run. In the next chapter, you can just explore the PMM as permanent magnet synchronous motor related examples are given to you, and this is the MLX file is given and SLX file also given. MLX means you can first read this MLX file. This is MATLAB based MLX file. So you can open this MLX file. In MLX file or live script file, everything is explained to you. PM, SMM, motor simulation and control. You can just study what is the background, what is field oriented control, Clark and everything is given, space vector modulation. Some theory part given to you. You can explore each and every chapter from this live script. Some images also given to you how this work. Okay, maybe after the theory it will insert some this one. So if you run this code from here, okay, if you run this command from here, it will open three-phase PMS drive DOS SLX. This example it will run, but you can also open this manually. After this reading this MLX file, you can open this example, and it has explained everything about your architecture. What are the architecture is used inside this, and you can run and you can simulate your PMMS. So example is given or ready-made thing is given to you. So this is step by step. You can explore this EV course, and this is a complete EV course, BEV course. What are the things are required further? I also discussed you one. This is called the SimScape battery. So either you want to work or design some type of battery. So we have a dedicated toolbox. This is called SimScape battery. So inside the SimScape battery, you have one on ramp. This is called the SimScape battery on ramp is given. So you can also do that one. But I want to just show you, if you go to inside the documentation of this physical modeling, and inside the physical modeling we have this SimScape battery. So inside this toolboxes, the theory is given, battery pack modeling or what are the different type of assembly is given, but I want to show you that what are the apps are available inside this toolbox. So there is one app is given to you, battery builder app. So using this battery builder app, easily you can just select different type of cells, assembly, and you can design uh, different type of series or your parallel assembly without writing any line of code. Okay. So how you can open this? The examples is given to you inside the code, inside this documentation, how you can create the object step by step is given to you. And once you are aware about the functionality of this app, you can directly open this app from the app section of MATLAB. So this is called battery builder app. So using the battery builder app, we can design, test our different type of battery or battery assembly. Okay. So this is either if you have the battery related data, you can also import the data, okay, in the mat file from the workspace if you have the battery related data. Okay. Then if you want to just generate a cells from the cells, you can example cells is given, then example assembly is given to you. Okay. Then you can just make the module, and you can also pack the battery pack. Okay. So step by step everything is given. Either you want to just parallel assembly, module assembly, and duplicate, you can quickly generate the battery. Okay, you can just insert the feature of the battery. Okay, and you can export that particular battery into XTL file also, okay? Or mat file or workspace. So this is for your battery designing app is there. Okay. So there is dedicated toolbox inside the MATLAB that we have. This one, okay. Further, if you want to explore, so my colleague will be discuss this more chapter on the thermal modeling. So after today or tomorrow, maybe tomorrow he has I think 2 or 3 days. Yeah. So thermal modeling, he will explore this example more, and these two chapters also my maths colleague will also discuss with you of powertrain modeling. So there are I discuss you two technique like modeling of any system. We have the mathematical modeling approach. We can use the Simulink component as well as we have the physical modeling approach. With the help of the Simscape, you can also uh, develop your EV or simulate your EV modeling of EV. But apart from that, if you want to work on your powertrain systems, okay, it is not part of powertrain system, not only the part of the EV, it could be useful in the your maybe some metro train or some lift type of application you want to design your or your where the powertrain could be useful. So or we have this dedicated toolbox. This is called powertrain block set is available. So if you go to inside the powertrain block set, so more quickly, all the different part of the EV also given, different type of assembly also given to us. So if you go to the here inside the Simulink, so apart from designing your EV, like we have just explored this BV example, this is mostly we have a we have this powertrain block set. So inside the powertrain block set, we have different type of drive trains. Okay. And as you know, we require the drive cycle if you want to test your vehicle on the different drive cycles. So drive cycles functionality also given inside this your block set library. So different type of components available here related to energy storage, DC to DC converters. Okay. So here with the help of this library, you can more quickly design your any type of powertrain models. Okay. So this library or will be useful to you once you are going to work on. So you can also explore this powertrain block set from the documentation. So it will be useful for you. So the this I will just shown you that how you can just start somebody new that what are the things are required related to MATLAB and what are the learning resources are available. Uh, During the whole course, we'll mostly talk about two type of files here. MLX file, what is how you can open the MLX file. So step by step, either you can just switch to any chapter or there is one reference file we have just created to you. You can also open this. So inside this document, you can also go to step by step, or you can just also follow the some main file. Okay. After completing this chapter like EV dynamics or your EV system, so some design project also given for your hands-on purpose here. Okay. So vehicle system design. So from this you can start just exploring this some reference model is given to you inside your chapter number 15. This is BEV model. It contain and it is tested on the different drive cycles. Then you can divide your complex program into some smart part. So this can say that MATLAB and Simulink just provide you the complete environment for your EV modeling. This is from my side. Just I hope that you got some idea about the MATLAB Simulink and how it will be useful. So if you have any question related to this one, so
Now the platform is open to all the participants for the questions.
आवाज नहीं आ रही.
Am I audible, sir?
Voice is little bit low and audible, but
I think. Is it okay now, sir?
yeah, ma'am, you can carry, but voice is little bit low.
Okay.
No.
Platform is open to all the participants for questions and answers. Any question from the participants? Okay. So I think, sir, the explanation that you have given is always it is the self-explanatory. So if there will be any query, we will be sharing your email ID with the participant.
Yeah. So this is the just you can just fill up the feedback if you want to connect, if you require any particular query. So I will just happy to help to answer. And let me share my email ID also share into. So this is my mail ID if you want to connect, or either you can fill up.
To all the participants, the recordings of the sessions and the presentations of the all the sessions will be shared with you. So I think that will be solving your some network queries as well. We understand network issues while we are being connected online. So we will be sharing the recordings as well as the presentations of the experts. Right. So before formally closing the session, I would request all of you to please turn on your webcam so that we can have a group photograph, please. Sir, may I request you to please.
Okay.
I would request all of you your webcam.
Good evening, sir.
Good evening.
Sir, can you please once again share your mail ID in the chat box?
Sure.
Sir, one more thing. For third year students, they are having multidisciplinary subject as this electric vehicle modeling using the MATLAB or like that. So they are having, they have to perform their mini projects. So what kind of mini projects we can get it performed from the students?
Ma'am, I just shown you the different complete EV model, but if they want to perform the mini project, you can divide this complex task into like your BLDC controlling, whatever the chapter I have discussed, your dynamics of the EV, or they can build any type of mini project on that one. Battery management, BMS, designing of the battery, you can show the SOC. So there are lot of multiple projects or mini projects are given to you.
Sir, are there any standard references for that apart from the typical Google or like that? Any standard references to do the such kind of mini projects?
You can find out like we have the this is called, if you just go to on the MathWorks site also, like mathworks.com, and there is learning options are available here, and we have this student program. Under this student program, we have dedicated this of project ideas. Okay, this is given to MathWorks Challenge project program is also given, and all the projects are on latest technology, maybe Industry 4.0, robotics, wireless communication, computer vision, autonomous vehicles. So if you just go through in autonomous vehicle, so maybe you will find out some project ideas related to maybe EV also. Okay, but this is the page is given to you here. MathWorks Simulink Challenge Project Hub is there. Okay?
Okay, sir. Simulink Challenge Project Hub.
Yeah.
Okay, sir. Thank you, sir.
Sir, good evening.
Good evening.
Sir, actually, I was trying to make one Simulink model with hydrogen, like instead of air, complete air inside the engine, I was putting few part of hydrogen with the calculations. So I am stuck that engine. I have engine block. I have made with the combustion, all the combustion equations, and like electrolysis also I have made, air calculations also I have done. With connecting it dyno, I am getting some problem, like so I'll send you the model in zip folder, sir. I'll mail you. Can you please look into it? Like not now,
Sure.
obviously. Later.
Sure, sir. I will connect you later on. No problem. I will check it and reply you.
Okay, sir.
Any other query? Our next expert also has joined with us. So may I request, sir, once again to all of you to please switch on your webcam. We have not taken the screenshot yet. Mostly of you have not switched on your webcam. I request all of you to please turn on your webcam. Manoj sir, may I request you to please stop sharing your screen?
Okay. New sharing, I think.
No, just stop sharing, sir. The red, yes.
Yeah.
Yeah.
Yep. Rajput. P. Rajput has any question? You have raised your hand.
Thank you very much, everyone. Thank you very much, Manoj sir, for sharing your expertise with us. And the complete hands-on session would be very benefiting to all the participants. And we will be sharing the feedback sure with all the participants. Thank you very much, sir, for your session.
Thank you.
Thank you
Thank
very
you.
much, sir. Thanks to all the participants. We request everyone to please remain connected. Our next speaker, Professor Vivek Srivastav, sir, has joined with us. The session will be started in another 2 to 3 minutes. welcome our next speaker, Professor Vivek Srivastava sir, and he will be here for the fourth technical session of the 6 days FDP. First, before handing over the session to sir, I would like to introduce him. Professor Vivek Srivastava sir is the distinguished academician currently serving as the Professor and Dean Planning and Development in the Department of Electrical Engineering at National Institute of Technology, Uttarakhand. With extensive experience in teaching, research, and academic administration, he has significantly contributed to the advancement of electrical engineering education and institutional development as well. His areas of expertise include power systems, power quality, sustainable energy technologies, and modern engineering practices. Sir is well regarded for his leadership, scholarly contributions, and commitment to fostering innovation and the academic excellence. We are honored to have you on this platform, sir. And
We can't hear you, ma'am.
Yeah, Dr. Preeti, you are not audible.
am I audible now, sir?
Yes, now it's fine.
Thank you. Okay. So we welcome you, sir, for the fourth session of this 6 days FDP. And before formally starting and handing over the session to you, I would like to introduce you with all the participants. Professor Vivek Srivastava sir is the distinguished academician currently serving as the Professor and Dean Planning and Development in the Department of Electrical Engineering at the National Institute of Technology, Uttarakhand. With extensive experience in teaching, research, and academic administration, he has significantly contributed to the advancement of electrical engineering education and institutional development. His areas of expertise include power systems, power quality, sustainable energy technologies, and modern engineering practices. Sir is well regarded for his leadership, scholarly contributions, and commitment to the fostering innovation and academic excellence. We are honored to have you with us, sir, on this particular platform. And I hope that your expertise in the topic of reliability analysis will be more beneficial to the participants. The session is over to you, sir.
Yeah, thank you, Dr. Preeti.
Thanks.
Am I audible to all?
Yes, sir, you are.
Yeah, thank you. So first of all, I am thankful to the course coordinators, organizer, and as well as you for providing me an opportunity to interact with the academicians, scholars, and the industry persons for the course which is being organized on the topic of driving the future, sustainability, mobility through electric vehicle technologies and MATLAB simulation. So here I am going to correlate the next around 90 minutes, which is basic on the reliability analysis of the electric vehicle. So please confirm me if my slide screen is visible. Please, any one of you can confirm?
It's visible, sir.
Okay, thank you. So this is the topic for my talk. This is the introduction on reliability analysis of the electric vehicle. So my focus will be basically based on the reliability applications. What is exactly the reliability means, and what are the important features or parameters of the reliability analysis of any components on any system. In between, we will try to cover the failure of any components or any system. The tools we are using here, one is the FMECA and the another one is the FTA, fault tree analysis. Their comparison amongst both of them and how these can be applicable for electric vehicles. So focus will be moved on the reliability and the application on the electric vehicles. So these would be the major points which we would going to cover here. The initial starting with the introduction and motivation, Then we will go through about the few reliability engineering fundamentals. Then FMECA, this is the failure mode effective critical analysis methodology and case studies. Then one exam case study or the example of the electric vehicles. Then further we will move for the fault tree analysis, the combination or the comparison, and the reliability applications. So here, let's say it is a basic line diagram of the electric vehicle, how the system is working. Although I understand we are already a lot of focused on the electric vehicle design, maintenance, and the application part. So I will not put any consideration on this. So why at the time of the electric vehicle, the growth of the EV's adoption and the need of high reliability and safety to avoid any mishappening or any designing parts. So the challenges which we are facing in the EV designing, these are the battery degradation. It may be based on the function basis or the time parameters, power electronics stresses, the charging infrastructure issues, and the dependencies on the software and the AI applications. So how any system can be improved with the help of the preventive maintenance. In this case, we are going to identify the hazard. Hazard means any mishappening which can be impact on a human or on a system, and risk mitigation. So here, as I mentioned, the FMEC and FTA are the basic essential tools for the EV reliability assessments. So in a brief, I will take some ideas how we can the architecture of the EV, the system breakdown structure. When any breakdown happens in the EV, so this may occurs or this may observe in these following subsystems. These are the either battery packs and BMS, battery motor and inverter drives. It may be in the onboard charger and DC-DC converters, thermal management system, braking and the regenerative controls, vehicle control units, sensors, softwares. So here the advantage of the reliability studies are the identification to the component or the process which is critical to function and which moves to the failure or the mishappening of the EV. So this is the advantage of. So what we are moved to the finding the reliability modeling. So these are the matrices which are used for the EV analysis. These are the MTBF, mean time between failure, and mean time to repair. Failure rate estimations, that is denoted by the lambda, system availability, hazard rate progression, that is defined based on the bathtub curve. And of course, we are talking about the reliability, and definitely we requires the data which we can collect from the field, from the lab testing or the physics of the failure, or we can get the AI-based predictive analytics. So these are our data sources will be required for any kind of the reliability analysis. And why we are going for the study for the FMEC and FTA? Because these are the very structured identification of the failure modes, and this gives these methods gives the idea about the effect and the root cause tracing. This is also gives the rank failure for the risk priority number, that is denoted by the RPN, and it is a constructed based probability based FTA, and of course this will added the design improvement for the design for the electric vehicles. So when we start about the reliability theory, basically it is a general theory of the system failure that is developed by the mathematicians. So reliability theory, that was the historical developed to the describe failure in the aging of the complex electronics equipments, but the theory itself is a very general theory based on probability theory and the system approach. So the use of reliability theory was started, the major use of started in during the Second World War, and so onward. So why do we need the reliability theory approach? Because it provides a common scientific languages for scientists working in different areas for aging research and the anti-aging interventions. And the reliability theory helps to overcome descriptive specialization, and it allows researchers to understand each other's, and it provides the mathematical model allowing to explain and interpret the overstressed data and the finding on anti-aging interventions. So it is important to identify what exactly how the reliability is defined. So the reliability is defined as the probability, because we have already mentioned it is mathematics. So probability that an item, a product, or a piece of equipment or system. So it means we are saying it is covering the entire universe. Whatever is existing in the world, everything is having or linked with the reliability. So system will perform its intended function for a stated period of the time under specified operating conditions. So we can say that our focus, the reliability, give the ideas how long an item or any machine will perform its intended function without a breakdown. So these four the major or important terms are there. So probability will always lying between 0 and 1. The another one is the performance. So for this we have to identify some criteria to define when and how product will fail, and which also describes what is considered to be satisfactory system operations and time. So system working until the time t used to predict probability of an item surviving without failure for a designated period of the time, and operating condition. So this will covers the all environmental effects, humidity, vibration shocks, temperature cycles, operation profiles, and thus that corresponded to the stated product life. So when we are or an engineer or the researcher applies the reliability, so there the observance of the conflicts with the real world, because as per the scientists the probability is lying between 0 and 1, but the customer will expect a probability of 1 only. If he has paid for some amount for any product or a system, so he would expect the product will be works all the time. It means probability should be 1 only. Intended function, the product may be used in unintended ways and still be expected to the work. Similarly, the understated condition, the product may be operated outside the stated condition and still be expected to the work. And the prescribed procedure, customer may not have the required tools or skill level and may not follow procedure and still expect to product to work. It means the customer is not using the protocol for application of the product, but he will expect their product will works always. So there is a major conflict with the real worlds with the reliability. So when we will talk about when the reliability should be applied for any system. So the very simple reply is that from the cradle to the grave, or we can say the entire life cycle of the product is lying under the observation or the consideration of the reliability. So any products, when we have to start for generation or the starting of any product, so it starts with the concept, then it's moved for the requirement, for the stages, for the design, prototyping, qualifying, manufacturing, test, and the supports. So concept comes in the scientist mind and supports it at the customer end. So it is the entire cycle period where we have to, as a engineer, we have to collect the data for developing the performance or improvement of the performance of the product and reducing the failure. So this is the failure is always lying between this curve. This is based on this curve shape. We defined it as a bathtub curve. So the failure rate is expected to vary over a life of a period of a product. So this curve we can divide into the three parts. You can visualize this. The first part is the infant mortality. This is denoted in the section of A and B. The second one is the useful life, denoted by the BC. And the third one is the wear out duration. This is denoted by the CD. So the X horizon is defined by the time and Y is the failure rate. So we can say in the beginning of any product, the failure increases with the time. So the early failures or the infant mortality, and the second part, which is the constant part. So after moving, reaching a certain age of the life, the product's life is remains constant. And after assuming or the consuming of the useful time, again the failure rate is being increased. So this, the entire escape or the graph is converted into the path of shape, and we can identify these phases based on the failure rate, the possible causes, and the improvement action. So the first phase, that is denoted by the burn-in. So here we can see these are the decreasing failure rate. So initially A is denoted at the higher side and B is at the lower side. So the failure rate is decreasing. The possible causes for these failure are the manufacturing defects, welding, soldering, assembly errors, part defects, the poor quality control, the poor workmanship, and etc. And the possible improvement actions are the better quality check, acceptance testing, burn-in testing, screening, highly accepted states screening. So the improvement actions are directly linked with the reliability, for the reliability or their life improvements. And the second section is a BC. This is the constant failure rate. From it has, there is no impact of the more or less failure is very constant or the very less. So here the causes are the environmental or any random loads. Suddenly at a particular instant, if stress is increases, then any chances of the lapses of the any product. This may be the causes of the human error, chance event, or the act of the God. So the improvement actions are the access the strength, redundancy, robust design, etc. And the third one is the wear out phase, that is denoted by the CD. Here we can again observe the failure rate is increasing. So this is based on the fatigue, corrosion, aging, and the friction. Because in the entire lifetime, after spending a certain time, the product is being moving for the aging effect. So this can be improved with the derating of the product, the preventive maintenance. This will give the idea for replacement of the components, part replacement, better material, improved design technologies, and etc. So how this is impacted? So when we can analyze here, this is the basic bathtub curve, and we are applying some failure rate and identifying the product life, and we are increasing the reliability. So the shape of this bathtub has increased. So it means the failure is reducing and the lifespan of any product is being increased, and still it will follow the bathtub curve. So when we will talk about any product, so here one example of the power electronics component, how the reliability is being implemented here. So first we have to keep some concept, then we will move for the designing. Designing is further subdivided in the analysis and preparation of the initial design, then verification and the optimized design. Here the important point is at the verification stage, if we are not getting the desired results, then we have to move for the further analysis and the redesign process of that components. If the verification is fine, then the product is moved for the optimized design. Then further it's a validation, production, and the release of any components. So basically it's a line diagram for the any electronics components. And this is the prediction box, how we are getting the data for the calculation for the entire reliability tools. So here we can see a lot of tools are given in the, especially in each blocks. So different tools are given. So few points like HALT, HAS, CALT, and the FMECA. So here the different stages are there when we have to perform the FMECA. So this was the basic reliability, and now we are moving further towards the failure mode effects analysis and the FMECA. So this is a tool. So the importance of the FMECA, it helps to identifying the component or the process with functional and the operational states for successful operation. All failure modes and the effects of the above components causes, what are the reason for the failure modes, methods for detection and correction of these failure modes, and effect of failures on other components of the systems. So basically the all these data is captured in a table which covers these details: component identification, function status, the failure modes, failure causes, effect of the system, detection means, operator actions, and the comments. So FMECA is further improved with the FMECA. So this is added, the term is C, that is denoted as the critical analysis. So it is a methodology to identify and analyze all failure modes of the various part of system, the effect these failures may have on the system, and how to avoid the failure and or mitigate the system of the failures on the system. And these are the importance. The use for the FMECA gives the design alternatives during the early design phases, and it ensures that the all conceivable failure modes and their effects. So FMECA, the output of the FMECA, that it will give the all failure modes and their effects on the system, and it also lists the potential failures with the severity, and it develops the early criteria for test planning and the test requirements, and it is also provide the historical documentation for the future references. That is a failure, a field failure. Hello.
Yes, sir.
Yeah, please. So is there was any network disconnection was there?
Just 1 minute back only, sir. Otherwise, it was okay.
Okay, where I was?
On the previous slide, sir.
Yeah, maybe like this only.
Yes, sir. Right, sir.
So whenever we have to perform FMECA, so the focus for finding the FMECA, so we have to check the or verify the every parts how it gets failed and what is the mechanism which might produce for these modes of the failure, and what will be the effect if the failures did occurs, and the happening failure, it is whether it is in the safe mode or the unsafe mode, and how the failure is detected, and the provision which provides the design to compensate for the failure. So as in the flow chart also of the electronics component, I have shown that FMEC is performs at every stage. So here we are covering, showing with respect to the cost and the FMEC performance. If FMEC performs at the concept or feasibility level, it covers around 3% of the total project cost. And if it is performs at design or development level, it is requires 12% of the total project cost, and at the time of the production 35%, and the operation it covers the 50%. So it is always better to initiate FMECA at early as possible to reducing the cost and the market viability. So there are three different types of the FMECA. One is a design FMECA that is carried out to eliminate failure during the equipment design. So in this case, all accounts, all types of the failure during the whole lifespan of the equipment. Process FMECA. So it is focused on the problem stemming from the how the equipment is manufactured, maintained, or the operated, or the system FMECA. So it looks for the potential problems and the bottlenecks in larger process, such as entire production lines. And approaches, it has the two different approaches. One is the bottom up and another one is the top down approach. So bottom up approach is useful when the system concept is decided and it is complete since all components are considered, and the top down approach is used in the early design phases before finalizing system structure, function oriented, and it starts with the main system function and how these may fail, and it may be applied on the existing system to focus on problem areas. So there are some standards, industry standards, which are being applicable for the any kind of the FMEC in the industries. And here we are covering the main steps which is required for the FMECA analysis, some prerequisites, some structures, failure analysis, and the team review. So prior to start FMEC analysis, one has to define the systems. So system definition is covers the system boundaries. What will be the function of that system and why we are creating or developing the system performance, and it will also cover the main system missions and the function, operation, and environmental conditions. So along with this, one has to collect the all available information. These are with the drawing, specification, schemes, component list, interface information, functional description, and the previous history based on the software's data, either Faracas or the interviews with the personnel those have been engaged in the previous FMECA construction. So now the system structure. So first we have to identify. So divide the system into manageable units. So this is a hierarchical design that can be used for the such task for the system, subsystem, and further it is divided into the subsystem level 2, or further we can go ahead with the component level, component and subcomponents. So based on this diagram, we can divide any kind of the system, and this is a functional block diagram that can be particularly useful for the sum system. And the structure, the analysis should be carried out on as in high level in the system hierarchy, and if unacceptable consequences are discovered on the level of resolution, then the particular elements, it may be system, subsystem, or the component, should be divided into the further details to identify failure modes and failure causes on a lower level. And to start on a too low level will give a complete analysis. So whether one side it is an advantage, if we are moving towards the component level, we can get a complete analysis, and sometime it is time consuming as well. So I would advise you take a snapshot of this table, because in the further slides we are discussing with these numbers which is given here 1 to 12. So basically the entire FMEC table is divided into the three categories. One is the description of the unit, another one is the description of the failure, and third one is the effect of the failure. So these are the basic information which we have to work out. So first, as given here, the reference number, every components, when we dividing the entire system up to the subcomponent or the component level, so each component would be given a identity or a tag number or the some reference number. And once the component is identified in the reference column 1, we have to list out the all function which is carried out with based on these components. So here the column 1, a unique reference to an element, it may be the subsystem or components is given, and it may be a reference to an ID in a specific drawing or so-called a tag number or the name of the element. And the second column would define the functions of that elements. It is important to list all kind of the function. So here we can put a checklist that is useful to secure all functions that is covered. And in the next column, we will write the all operational mode of the elements. Like say, if we have defining for the general system, so it may be the ideal or the standby or the running, or let's if we are taking any aircraft, so the operational mode will be the either taxi, takeoff, climb, cruise, descent, approach, and flare out and the roll. So these are the different various operational modes. So we have to list out all operational mode of our components, and in the next column we can identify the failure mode of each function and operational mode of an element. So here the failure mode should be defined as a non-fulfillment of the functional requirements of the functions specified in that column 2, and the next column will give an idea of listing the all failure mechanisms that the processor contributes on a failure modes. And the next column will give the all possibilities for detection of identification failure mode should be the listed. Here the column 6, it means we are completing here the failure part. In the column 4, we have identified the failure mode. Column 5 has covered the failure cause, and the column 6 has defined with the detection of the failure. And now the next portion, the effect of failure. So here, what the impact is occurred on the subsystem. Subsystem means the local effect. If some failure is observing, how it is impacting on the nearby components or the nearby system. So this is known as a local impact, or on the system function, it is a global effect. How a failure of any component is affecting on the performance of the entire system. So these we have to identify with respect to the each operation mode, or we can say the each function stages. So now after this we have to move ahead with the failure rate. Failure rate basically its identification, the ranking, how we can identify the ranks. If the possibilities is very high that the defect will be detected. If failure is very easily observable, so we can rank them as a very low level, let's say 1 and 2. Here the verification and or the control will almost certainly detect the existence of a deficiency or the defect. The next level, the high probability that the defect will be detected. So the 3, 4, moderate probability the defect will be detected. It can be ranked as a 5, 7, and low probability that the defect will be detected with rank as a 8, 9. And if the very low probability that the defect will detected, it means chances are very rare to identify any failure. So this means the risk is the very higher side. So we are ranking here it as a 10. So here then the column, here the list failures, unlikely once per 1,000 years, remote 1 per 100 years, occasionals, probable once per year, and the frequent once per year. So the next will give the severity ranking for the worst potential effect of the failure considers. So the higher the loss, higher the rank, severity. So the highest which we have given here is the 10. Catastrophic, that is, it means the failure is converts into either the major injury or death of the personnel. So highest ranking would be given for in such conditions. In the critical case, ranking may be given between 7 to 9. So the failure results into the minor injury to the persons or the exposure of the harmful chemical or radiations, or fire cases. For the major severity classes, categorized into the scale of 4 to 6. So here the failure results in a low level of the exposure of the person or activates facility alarm system. And 1 to 3 is the severity class, is the minor, where very small damage but not cause of the injury of the personals. So the life of the personal is having the highest severity. So we are considering as a rank 10. And some in some different authors or the scientists are having the different ranking pattern, but it is also lying between 1 to 10. So here in the next column, we can write the possible action to correct the failure and restore the function to prevent serious consequences that are listed here. And these are likely to reduce the frequency of the failure modes. And in the last column, we can record the pertinent information that is not included in the other column. So here the main scale or the outcome of FMECA is the risk priority number, that is RPN, and there is nothing but multiplication of the SOD, where the O is the occurrence of the failure mode, S is the severity of the failure mode, and D is the detection. Higher the SOD will be the move for the higher the RPN. So the table will give the output in terms of the number, which is RPN. So whenever any components will have the higher RPN, immediately we have to move for the preventive actions or the taking the necessary measure to reduce the RPN, and which may be the help of the OSD. So this is the alternative FMECA, and FMECA team is constituted by the various design engineers of the plant or the production line. So these may be the project manager, design engineer, test engineer, reliability engineer, quality, maintenance, field services, and manufacturing. So based on this RPM, how we can change the RPM? The team maybe suggest the design changes. They can suggest for engineered some safety features. They can suggest for adding some safety devices, warning devices, and provide some additional procedure or the training to the workmanship involved here. So this is one example how the RPN can be reduced. If initially the RPN is 280, the occurrence severity and detection is given as the 785, and the RPN is denoted by the multiplication of the each occurrence severity and detection. This give a number of the 280. So based on the revision or the recommendation of the team, we are making some changes. By this, the occurrence is reduced by the 5, severity is remains 8, and the detection is a 4. So that gives the final RPN number is by 160. So there is a reduction of the RPN in the 43% in the initial and the revised condition. So accordingly, whenever we find any increasing in the RPN, we can reduce it. So these are the comprises the main 3 phases: identification, analyzing, and the act. So some pros and cons of the FMECA. So here we can see it is a very structured and the reliable method for evaluating hardware and the system, because we are analyzing FMECA at the component level, And the concept and application are very easy to learn, and the approaches makes evaluating even complex system that is very easy to do. And cons, of course, it is very tedious and time consuming and expensive as well, because we are covering the entire process and a huge team in the formation of FMECA. And it is not suitable for the multiple failure and very easy to forget any human errors. So one example of the PV system here, just you have to remind the steps. So first we have to break down the entire system into the small components. The short system, Stinger power conditioning system. So what we are doing here, we have identified the system. System is the entire source system, further divided into the subsystem. So subsystem is identified as the PV module, rack, and the cable tray. Components are the aluminum frame, junction box, cables, front glasses, and every component which are having the subcomponent, we are writing their subcomponent as well. As the junction box, it is having the subcomponent of the junction box, case, sealing, contacts, and bypass diode. So by this mean, we are dividing an entire system based up to the component of the subcomponents level, and it is the combination of the all kind of the subsystem as well. Then further, we will identify the failure modes. So here, this analysis identifies 77 failure modes, out of which 29 are the PV modules. So the listing is here for the PV modules, and based on this, we can analyze reason for this failure. It may be the mechanical damage or the thermal damage, delamination, corrosion, UV exposure, extreme weather condition, high voltage stress, shedding, and the animals. So the effect for on the modules due to these failures, it may be either energy outputs, energy safety, overheating, arcing, or we can see this is the FMEA of for the fuses. One example. So what we are doing here, we have identifying the failure modes of any fuse. So fuse may be fail if it keeps the open intermittently, open sparsely, high resistance, open early, open late, and fails to open. And every failure mode is having its potential effects. What are the effects would be there if a particular kinds of failure occurs, and their potential causes is also recorded here. Like say the if open early, it means there would be the no energy output, and the causes will would be the bad system configuration or the human erroneous action or the construction defects. So these are the few probability risk assessment events, initiating event when we find out the risk. So we have divided the initial state and the end state and apply the inventory for the loss of the grid electricity. So here the first node would be the initiating event, that is the loss of grid electricity. Then FE1, FE2 failure event 1, failure event 2, failure event 3, and the end state. So if the initiating event are the loss of grid electricity, then the various stages. So here, the two state we have to consider either success or the failure, and based on the stepping, we can get the some numbers or outcome. Accordingly, we can identify the mode and state of the failure. So here we have denoted the notation 1, 2, 3, 4. Like if all conditions or the states are in success mode, so there would be failure of the electric safety issues. In the second case is the no power success, and the third case would be the improper power to the grid, and fourth would be moving for the structural damage. And this is the end inventory for the extreme wind loads, and some examples are there. So here this is the some line diagram. Whenever we will take any component, we have to break down its component level and write down in a FMEC table and move ahead. Now, when we'll move for the electric vehicle. So here, as of now, we have covered the FMECA steps. So we have to apply FMECA for the EV. So first, identification or breakdown of the system into the subsystem levels. Then identification of the all components at its failure modes, their effect and causes of the failure. Then severity, occurrence and detection of the ranking for each components. Then calculation of the RPN, criticality number, and prioritization in the mitigation plan. So when I'm not considering here the line diagram, the points I'm considering here, the important parts or the important subsystem or the subsystems are the battery and BMS management. So the failure possibilities for battery and BMSs are thermal runways, cell imbalance, over voltage or under voltage failure, or sensor and calibration errors. For the motor and power electronics failure modes are the IGBT or the MOSFET failures due to the thermal cycling, DC link capacitor degradation, bearing failure, insulation breakdown. While we will talk about the charging system, so the failure modes may be the connector overheating, charger control faults, and EMI EMC disturbance. And for the control and software systems, the failure may be the firmware bugs, sensor drift, and CAN bus communication failures. So based on these failure modes, we can move ahead for the failure analysis table, and this will give the results related to the high risk failure mode, severity distributions, component criticality ranking. Again, the ranking is identified based on the RPN and recommended corrective action. So action may be the redundant sensing, providing the alternate path or alternate components, and the improved cooling, derating, and the AI based monitoring. So these will be the correct assessment results based on the FMECA. So this would be the some kinds of the FMECA table. So have a look on this and try to correlate which we have started the table with FMECA, the different columns and the different steps. Have a look for 1 or 2 minutes. Try to read out. So here in the first column, the all system and components are written, their related functions, their failure modes, effect, their severity, causes, occurrence, and detection. So initially RPN is a 120. So each row is having some particular RPN, 120, 108, 140, 192, 82, and so on. Now, after getting the RPN, the recommended actions are suggested by the team, and some honor is allowed and due date is given. So based on further recommendation, we are reducing the numbers, and 120 is reduced by the 36, 42, and so on. So by this mean, we are reducing the risk. So this is useful for the entire AV pattern. And now the second tool is the fault tree analysis. So here the fault tree analysis. So what is the fault tree? It is a basically top-down approach to failure analysis, which is starting with a potential undesirable event. So this is basically considered as an accident. So that would be called as a top event. and then determining all the ways it is happens, and the analysis proceed by the determining how the top events can be caused by individual or combined lower level failure events, and the cause of the top events are connected to the logic gates. And here the logic gates which we would cover is the AND gate and the OR gate, and it is most commonly techniques for the causal analysis in the risk and reliability studies. So initially it was started or used in 1962 in the Bell Laboratories with the safety analysis of the Minuteman missile launch control system. And further, this was improved in the Boeing company, and it is extensive used and extended during the reactor safety studies. And the main steps for the FTA, here the defining the system, the top events, or we can say the event which is highly undesirable, or we can say the potential accident and its boundary conditions, construction of the fault tree, identification of the minimal cut sets, qualitative analysis of the fault tree, quantitative analysis of the fault tree, and the reporting of the results. So for identification of the fault tree, the starting points of any FTA is often an existing FMECA and a system block diagram. It means we have to have results of the FMECA and the block diagram in our hand for moving for the FTA. And the FMECA is an essential first step in understanding the system, and the design, operation, and environment of the system must be evaluated, and the cause and effect relationship leading to the top events must be identified and understood. So basically, it's a preparation. We have to have a FMEC and the system block diagram, and based on input of both these components, we have to develop the fault tree. So the topmost event is the undesirable event or the failure. So the boundary condition, the physical boundaries of the system, it means the which part of the system are included in analysis and which parts are not. So it means one has to decide the boundary lines where in which has to work out. And the initial condition, what is the operational state of the system when the top event is occurring. The boundary conditions with respect to the external stress, what type the external stress should be included in the analysis, the VAR condition, sabotage, earthquake, or the lightning, and the level of the resolution. It means the how detailed should be the analysis. So whenever one has to perform the fault reconstruction, he has these three W in his minds, that what is happening, where, and when. So here the example is given. If a fire is observed, where? In the process of the oxidation reactor, and when? During normal operations. So in this case, what are the immediate necessary and the sufficient events and conditions causing the top events? And these must be connected with the help of the AND and OR gate, and the proceed in the way to appropriate level. That is the basic events. Appropriate levels are the independent, maybe the independent basic event, or the event for which we have the failure data. So these are the gates and their synonyms or the components which we are using in the fault tree analysis. So when we will talk again, come for the EV case. So here we are taking the example for the propulsion loss. So this will include the top event. The top in the case of the propulsion loss, the top event would be the loss of drive torque. We are not getting the drive torque. So the branches are there may be the motor failure, inverter failure, or the DC bus faults, the battery supply interruption, or the control signal error. Based on this, we will move for the quantitative analysis, and further we will generate the cut set, and the minimal cut set will give the reliability importance measures. So different methods for the minimum measures of the Fusel-Wasley measures for the reliability analysis. The better thermal runways for the fault tree analysis. These are the causes due to the internal shorts, cooling system failures, overcharging, and the mechanical abuse. And the probability evaluation and the risk mitigation using the fire resistance material, multi-level protection scheme, and the AI enhanced thermal monitoring. So when we will integrate FMECA and the FTA, so we can see the FMECA is a bottom-up approach preferably, while the FTA is always top-down approach. FMECA is identifies all failure modes, and FTA identifies causes of a top event. FMECA is the analysis based on the component level, and FTA performs at the system level. And FMECA helps in design improvement, and FTA helps in safety certification. So these are the two methods of how we can perform it. And for further research purpose, I want to include few points which is used for the reliability point of view for the EV research. So we can go for the AI-based fault prediction, the online health monitoring, the digital twin of battery and the motor reliability and remaining useful life estimation, and the integration AI-generated failure probabilities into the FMEC or FTA. And here the few standards and the compliances which are necessary for the reliability studies of the EVs. And these are the IEC 60812 for the FMECA, IEC 61025 for FTA, ISO 26262 for the functional safety, AIS and BIS for standards for EVs in India. So based on this, we can go for the implementation of the reliability. So this is all for the basic idea about the reliability studies from the EV. So I have tried to introduce learning about two tools here. So you may ask any kind of the points which is related to FMEC and FTA. I hope I would be able to give you some idea.
Thank you very much, sir. Now the platform is open for all the participants. If there is any question, you may ask, please. Any questions from any of the participant? I think so. There is no query from the participants.
I believe it's similar to some different area to apply the reliability. So, and if any participant have any query in later stage, they can also ask me through email or contact me through WhatsApp. So I would be I would be happy to share more details about the reliability tools for EV analysis.
Right, sir. So one query is there, sir, from Ms. Monica Shekhawat in the chat box. For energy optimization, which technique is best?
So if we are here, basically it's a different zone. It is not directly linked with the reliability calculation.
Okay. I hope that addressed the query, Monica ma'am. So with this, we are about to close the session for today, and I've shared the feedback link for the fourth session in the chat window. So you all are kindly requested to please submit the form. And sir, before closing the session, I would request to all of you to please switch on their webcam so that we can have the group photograph with you. So may I request you to please stop sharing the screen? And I would request all of you to please switch on your webcam as well. Sir,
Just a minute.
okay.
Is it?
Now it's visible, sir. It's okay. Thank you very much, sir. And thanks to all the participants for having patience hearing. And tomorrow we will be meeting again at the same time, 6 o'clock, for the third day of the FTP. So thank you very much, sir, for sharing your expertise with all the participants in this particular area of reliability analysis. Thank you very much, sir.
Thank you.
Thank you very much, sir. All the participants are requested to please submit the feedback. The feedback link is already shared. Okay, I'm sharing it again. Some of you are asking. Just give me a minute. I've shared the yes, Sahil. You can leave, but please before leaving, submit the feedback form. Right. Thank you very much to everyone. We will be again meeting tomorrow at 6 o'clock. Session 3 was already shared earlier. I am again sharing the link in the chat window. If someone has not submitted, you may please submit. I am again sharing the link of the session 3 as well. Please wait. I've shared the link for the session 3 as well. So all of you are requested to please submit the feedback for both the sessions of today. Thank you, everyone. So we will be stopping for today and we'll be meeting again tomorrow. Thank you, everyone. Rahulji, you may please stop the recording now.
Okay, ma'am.
Okay, thank you. So now we are ending the meeting. Thank you, sir. Rahulji, please end the meeting now.